Hello everyone and welcome back. My name is Calvin, and in this series we're going to talk about how you can leverage the Terraform modules created by Palo Alto Networks to deploy a new cloud reference architecture by automating through Terraform Cloud. Let's say, for instance, that you are the automation expert for your organization, and the cloud security team has approached you with their new shiny cloud security reference architecture and tasked you with automating their rollout across their environment. Now, as the automation expert, you might feel a little bit overwhelmed by these security architectures. That's what we're hoping to solve for in today's video. What we're going to do is we're going to start off with some of the existing code provided by Palo Alto Networks. Then we're going to clone it to our local machine, where we're going to make some modifications to tailor the project to work for our specific requirements. Now, once complete, we'll then move to create a new GitHub repository and push our code up into it. And finally, we'll take this GitHub repository and attach it to a new Terraform Cloud Workspace, where we can deploy our new cloud reference architecture through Terraform Cloud. By the end of this video, you're going to be able to take advantage of the Terraform modules produced by Palo Alto Networks to roll out your own cloud reference architecture or base them off of the examples that we've provided. We're going to go through each process step by step, making sure that you have a clear understanding on what you're required to accomplish in order to get the job done. At the end of the session, we'll have an additional talking point around additional considerations that you should have when going into production. But before we begin, let's talk about a couple things that you should already know going into this video. You should already have a basic concept around what Terraform is and how it operates. Understand the differences between a Terraform plan, a Terraform apply, and a Terraform destroy. You should also have a free Terraform Cloud developer account. Actually, I don't even think it's a developer. I think they just opened up the license. So there is a free tier within Terraform Cloud to take advantage of. You should have a basic understanding on Git operations in order to interact with GitHub. You don't need to be an expert by any stretch of the imagination, but there will be no explanation to the Git commands that are being executed. So having a little bit of knowledge in that domain won't hurt. Well, that about covers the introduction. Let's go ahead and start off by talking about the AWS EC2 Dashboard. Looking into my EC2 Dashboard, I can see that we're starting from a clean slate here. Now, if you're unfamiliar, EC2 is the service that AWS provides us to build and manage our virtual machines within their cloud environment. And in mine, I can see this region, I have only a single SSH key pair, of which will be pushed to the firewall through Terraform. But outside of that, we are starting from a clean slate. I wanted to bring awareness to what the dashboard looks like right now, because when we get into the post deployment, this dashboard will be what we reference to monitor the health of our infrastructure. And just like that, we are done with our first section. Let's now move into a much longer section where we're going to actually be referencing the examples, a repository from Palo Alto Networks. We'll be cloning it to our local machine, making a few modifications here and there, and creating a new private repository to push our code up into. Here we are at Terraform's registry. This is the place where developers can publish their providers and modules. In our case, we're going to be looking for the VM series modules published by Palo Alto Networks. And in my case, I'm going to be specifying the AWS instance of these modules, but just know there are GCP and Azure and others as well. Now, when we arrive at this page here for the modules, if we click on the drop-down menu, we can see all these different reference architectures that we have the opportunity of basing our design around. Now, each one of these has its own strengths and weaknesses, and that will not be part of today's conversation because we will never leave this video. Instead, we're just going to focus on one specific design. In this case, we're going to be using the combined design here. Now, by clicking on the link at the top, I'm redirected to the source code where the modules and all the documentation is found. This is also a place for me to look into examples for the deployment. But as you can see on the left-hand side, we have access to all of the source code for the modules. So if we wanted to get a better understanding on how these modules are actually put together and how they're doing their magic, we can go that route. Or we can go back to the documentation and we can read up on information about the modules that are be used for our specific design, as well as get some insights into the inputs and the outputs of various variables and resources throughout the usage of this specific design. Now, we're going to take a shortcut here, and we're actually going to clone the entire repository down locally. There's a couple of ways that we could actually approach this. We could reference the modules directly within a new Terraform configuration file. We also could fork the repository, but I have a problem with the forking just because you can't natively make a forked repository private. So in our case, I'm just going to clone the repository to my local machine and then rename the directory and start my cleanup from there. So with a simple git clone operation in the URL to the repo, I'm then able to do a move command, which will help me rename the downloaded folder to VM series-AWS-Terraform Cloud. And then I can open up a new instance of VS Code within this project and get to see all of my local files that were pulled down from the example repository provided by Palo Alto Networks. Now, this next stage is completely optional, but one thing that I like to do when I'm working from an example repository is to go through and clean out any of the files that aren't relevant to my deployment. So in my case, the root directory is only going to have the license and the README from the original project. I'm also going to rename the examples directory into source or SRC, and then I'm going to create yet another top level directory called AWS, and I'm going to store everything related to my AWS deployment inside of that directory. The reason why I like this type of folder layout is that there will be times where I'm working on a repository that has two different functions. Let's say, for instance, at the root level, we have a folder called AWS, and it manages all my deployment and lifecycle maintenance of my virtual machines and VPCs and all those goodies. But then I have another folder called PanOS, which uses a different Terraform provider to manage the configuration of the firewalls once they're online and operational. Those are two completely separate challenges and require separate modules and providers. So I like a firm delineation of church and state in this case. So anyway, this is kind of why I've arrived at this folder directory structure that we're going to be working with today. But again, it's completely optional and up to you as how that you put all these things together. I'm also going to go through the former examples, now source directory, and remove any of the designs that are irrelevant again for my deployment. I'm only going to be pushing forward on the combined design, so everything else is really just waste. This is also a really good opportunity to dig into the modules source code yet again. These modules in this example repository, this is not static, right? They were built with the idea of customization and flexibility so that you can pull different modules together to create the infrastructure that aligns your new reference architecture. So having some good familiarity with the variables, the inputs and the outputs, and again, just how the Terraform configuration files are structured will do you a great favor in the future when the inevitability comes to start with customizing. Now, one of the things that I need to clean up here is there's a hidden folder called .git, and this came from the repository when we did the clone operation. And if we look into the configuration file inside of this hidden directory, we can see that it's still pointing to Palo Alto Networks public repo. And this is not going to do. We don't want to affect anything in their repo. In fact, we're going to be creating our own private repository, so we want nothing to do with them. So what I'm going to do is I'm going to go ahead and remove this hidden Git directory. This will kind of set the stage for us in the future when we need to add in our own Git repository configuration. One other thing I want to do before we start working on the repo is I'm aware that we moved a lot of files and folders around, and I want to be able to validate that my folder directory structure is still going to work. So I'm going to change into the Terraform source directory here. I'm going to perform a Terraform init. What this does, outside of creating a local state file and downloading the providers, more importantly for us, it's also going to validate that the directory structure that my modules are in is legitimate, that it's not going to break. If we had moved some things in the wrong way or structured our folders incorrectly, we would have had a failed initialization here. So we know that we're in good shape. I also just want to validate that my my AWS credentials are actually working. We will be using these credentials inside of Terraform Cloud to authenticate with AWS. So it's a pretty good opportunity now to also validate these with a Terraform plan. As you can see, I'm pointing to an example file called example.vars. No context on this file just yet, outside of just sharing with you that it holds all the values that will be passed through the modules themselves. It's a very important file. We will be covering it very shortly when we talk about Terraform variables. Now, from the plan output, I can see that we're about to create 211 resources, and a good scout would go through all 211 and make sure that those check out and match your expected results. But for the purposes of demonstration, we'll just wink and say, yes, we definitely reviewed all of those. Now let's go back into GitHub and create our repository to where we can push all of our project files. So back up in the GitHub user interface, I'm going to click on New Repository. And the most important piece on this page is to make sure that your project is set to private. And also leave off the README, the git ignore, and the license. If you select any of those options, those last three options, it will auto-generate some files and it will mess up our Git operations, so just leave them out. Now, we will be rewarded with this set of instructions on how to push our project files up into this repository. The first line we can omit because we already have a README file, so it's not relevant to us. But just copying the commands to our clipboard and returning to VS Code, I'm going to navigate to the root directory of my project and paste in the instructions that we got from GitHub. Now, what this should have done is this should have pushed just a single file up to GitHub, and this will be the README file. So if we refresh here, we can see, yes, we have one file in our directory, and it is the README file. Now, this was a good test just to make sure that all of our credentials and authentication works out for us. Now the task is to push the rest of our files. But before we get to that, I want to talk about something else. Because when we ran Terraform locally on our machine, what happened is that Terraform created a couple of hidden directories and some extra files within our project. Now, some of these files are all important in their own way, but some of them we don't want pushed to our GitHub repository, specifically things like binary files and secrets and those types of things. So I'm going to open up Google and I'm going to ask for a Terraform git ignore file. If you've never seen git ignore before, it's basically a set of instructions on which files should and should not be added to our Git operations. In our case, we can see that we're excluding some of the Terraform local files, like the Terraform state file is mitigated from updating, as well as the Terraform or anything with TF vars. Now this will pose a challenge for us in the future, but for now, let's go ahead and add it into our repository, and we'll cross that bridge when we're ready for it. I'm gonna go ahead and add all of my files within the directory now to the Git list and perform a basic commit operation and push it up into our repository. Moving back into GitHub, if I refresh my page, I can now see that my local Terraform files and the folder directory structure are now present within the repository. With the longest section now accomplished, we can shift our focus on to building our own organization within Terraform Cloud, connecting it to our GitHub repository, and then hopefully deploying our new architecture. Now, the very first thing that we need to do after creating a Terraform Cloud account is to create a new organization. Now, in my case, I've already created an organization here called Redtail, and we're going to be using that throughout the demonstration. But in this organization, you can see that I have no projects or workspaces defined. So I'm going to start off by creating a new project. This will encapsulate one or more workspaces for our environment. Maybe we have one for deploying VM series. Maybe we have another one for managing security policies after the firewalls are online. But once we've selected the project, now I can create a new workspace. And the type of workflow that we're going to select for today is a version control workflow. This will enable us to tie it back into our GitHub repository and all the adds, moves, and changes that take place there. Now, I've already connected my Terraform Cloud account to my GitHub repository, but should you need to select another provider, here are some options that you have available for you. On the next tab, I need to select my GitHub project, and I'm going to do that by typing in a quick filter. And now we can select the VM series AWS Terraform Cloud project that we're working with. And on the final tab here, we need to add some basic metadata about our workspace, but also how we want things to be executing. So I always encourage people to leave a helpful description, not just for your teammates, but also maybe yourself in the future. If you're ever looking at this workspace and thinking, what is this doing? Descriptions can be a really good attribute to point us in that direction. We also need to tell Terraform where in our project directory structure the root of our Terraform configuration files are. So if you recall, we moved a lot of things around at the beginning of this project during the cleanup. If you chose a different path, you would need to execute that right here. Under VCS triggers, I'm going to go ahead and leave the default, which is always trigger runs. This will suggest if any changes have been made to the main branch, that Terraform will automatically, or Terraform Cloud will automatically initiate a Terraform plan with those changes included in there. Now, when we create the workspace, Terraform Cloud is going to parse through all of the files and try to identify where our variables are. They're going to give us the option of passing in values for these variables here, which is amazing, but not fit for purpose, because from what I've seen, you cannot input complex data structures like mappings and lists in these sections. It can really only be string values or key value pairs. Now, I need to have a way for Terraform Cloud to authenticate with my AWS tenant. And the way that we're going to do this is we're going to create a new variable, but instead of creating a Terraform variable, we're going to select an environment variable and follow the AWS documentation on how to use environment variables to authenticate. In my case, I'm going to create an AWS access key. Again, making sure that I selected environment variables and we select this as a sensitive piece of data. We're going to be doing the same next for the secret access key. Again, please make sure that you specify sensitive in this case. This prevents other teammates from seeing what your authentication parameters are and also prevents them from showing up in logs. Finally, I have another variable called AWS region, which is not sensitive, and it is going to be equal to US West 1, which is where we're going to be deploying all of our infrastructure against. But now that we've got these three environment variables set, you would think that we would be able to execute our first run. Let's go ahead and execute this, and I'm going to tell you ahead, this is going to fail. And I want you to see this failure to get an understanding of what it actually looks like, but to talk through what our options are here. So I'm going to literally call this run, this will fail, and I'm going to select just to do a plan because, again, it will fail. And what we're going to see here is we're going to be greeted with a wall of red text that suggests that there are variables set or variables defined within our Terraform configuration files, but there is no value set for them. This makes sense. Remember on a couple of screens ago, we skipped the ability to define these whenever we had created our workspace for the first time. But if you think back to it, we didn't have this issue when we were executing this from the command line. So why are we having a problem in Terraform Cloud when the Terraform plan operation worked just fine from the command line? Well, let's cover that topic now. Well, we now have Terraform Cloud all set up. Congratulations. Now we need to talk about why our executions had failed with that error message of there being a variable defined but no value set. And in order to talk through this, we're going to have to revisit that example.tfrs file that we had shown in a previous section. So let's go ahead and start off there. Looking into example.tfrs, what we can see is we have a series of key value pairs that represent all the values for the variables of our Terraform configuration. And if I fold these all at the root level by the key, I can see the doc strings are indicating which parts of the configuration are affecting which parts of our deployment. For instance, if I look into VM series and unfurl the bootstrap options, I can see all of the bootstrap configuration that's going to be passed into my VM. I can also see which version of PanOS we're going to be declaring, as well as all of our interface configurations for both management, private, and public interfaces. So these are all of the values that come within the example project that we cloned from earlier. However, as you can see, there are a series of to-dos for us. These are instructions from the project maintainers on which things need to be addressed by us before we actually push this. So if I highlight to-do update here, if I highlight this and search upon it, I can see I have 35 different tasks that I need to fill in. Important ones too, like this one, which manages the who can talk to the management portal of the firewall, right? We don't want to leave it at quad 0. We probably want to update it more restrictive based on our own IP space. But the first thing I want to do is I want to change the region that we're going to be deploying in. So I'm going to search for EU West and I'm going to replace it with US West. Because if you can't tell by my accent, I'm in America. I'm also going to change the prefix for all of our infrastructure from example to redtail. And then I'm going to reference that SSH key back in our AWS EC2 instance that we had shown at the beginning of this. As a refresher, in the EC2 dashboard, if I come to key pairs and search on redtail-VM series, I can see that this is the only key within here, and just make sure that we have a match right here within the project. So now we've updated all of the values for our demonstration. I highly encourage you to go through all 35, but this is sufficient for me for now. I'm going to rename this file as terraform.auto.tfvars. Now, when I updated it, one thing that didn't change was any kind of status within Git. And the reason for that is that we created this git ignore file, which by default ignores any .tfvars files within our directories. Well, I want to make an exception. So down below, I'm going to add the path of our terraform.auto.tf-vars file. I'm going to place an exclamation in front of this. What this will do is it'll look at the top instruction where we ignored all tf-vars files, and then it will process line number 19, which will say, well, wait a minute, exclude this one tf-vars files from the previous statement on line 16. It's really important that you get this exclude functionality below the match on line 16. If the order was opposite, then you would not have a successful impact on here. But what happens when I update the gitignore file, you'll note on the left-hand side that terraform.auto.tf-vars suddenly turned yellow in my IDE. That's because there has now been an update for this file, or I'm sorry, not the U doesn't stand for updated, the U stands for untracked. So we have an untracked change within our project. In this case, the change is the creation of terraform.auto.tf-vars. And I can validate this by typing git status. And here we can see we have one file that's been modified, which is the gitignore. I'll go ahead and add that now. And then we also have an untracked file, which is the terraform.auto.tf-vars file, which has all of our variables. Now I'm going to go ahead and commit these two files by performing a git commit, and then I'm going to push them up into the Git repository. Now what's going to happen after this is kind of magical, so stay glued as we transition into the next section here. All right, now it's time for the magic show. And now, once we've pushed our files up to the GitHub repository, what do you think is happening back in Terraform Cloud right now? Well, let's go ahead and check it out. Now that we have our tf-vars file successfully added to our GitHub repository, I can see that we've got the commit message that says that we've successfully pushed the tf-vars, but I've got this little yellow dot next to it. And if I click on it, I can see that Terraform Cloud is suggesting that there's some pending changes going on. Let's go ahead and click on that link, and we will be redirected to the current Terraform run for our repository. This goes back to when we set up the workspace. We told Terraform that we wanted to actually do a Terraform plan whenever there's been a change made to the main branch. And that's what we're effectively seeing here. Terraform Cloud is automatically notified of the change to the branch and is now executing the plan ahead of us, which is amazing, right? We don't have to actually execute the Terraform plans ourselves. Terraform Cloud is smart enough to know to execute based on certain criteria. Now, if we review all of the 211 modules, which I know you just did, just like I did, we'll go ahead and say that looks good to me, adding our thumbs up for approval, and that will transition Terraform out of the plan phase and into the apply. Now with the magic of video editing, I'm going to press on the acceleration button here to go into ludicrous speed, and we'll watch the deployment actually take hold. All 211 resources are now being created inside of our EC2 instance through Terraform Cloud. All right, it looks like everything was created successfully. We have 211 in the green section and nothing in the red, which indicates our deployment was successful. And we are presented with some IP addresses that will help us now validate the health of our infrastructure. Now that we've successfully deployed our infrastructure to AWS, the task upon us is to validate the health of our infrastructure as well as running additional Terraform applies to see if any changes need to take place. And that's what we're going to be doing in this section. The first validation comes from the outputs that were presented to us after our deployment. We were given a couple of management IP addresses to access the firewall's management console. Now, if I try to browse to these IP addresses right now, you can see that the browser is not returning any data back. Now, this will become clear as to why when we return back to the EC2 dashboard. Here, when I click on running instances, what I'm going to notice is that of the virtual machines that we have listed, the two that are the firewalls are still in the initialization phase. This means the firewall is still going through its boot up process and is not ready to accept a management connection over HTTPS or SSH. So we're just going to wait a few minutes. Now, when I refresh my health of my instances, I can see they have now moved into the ready phase. And if I browse to these external IP addresses again, what I notice now is I get a PanOS login for the management console. So suffice to say that the firewalls are online and operational. Let's go back and do another form of validation by returning back to our Terraform project. And here, we're going to run another ad hoc run where we're going to validate whether or not the infrastructure is healthy, or if any changes need to take place, or if we're connected to the transit gateways. And now the response that we get back from the plan is that there are no changes necessary, that the current state of the cloud infrastructure matches our declared state within our configuration files, which is wonderful. Now let's just do one more test. We'll literally give it the name of one more test. And I just want to make sure that my infrastructure is exactly as I say it is. And the response we get back from the Terraform plan is yes, nothing to do. Everything matches exactly what we declared within the project. With our infrastructure deployed and validated within AWS, there remains just a single task for us, and that is to destroy everything that we've done. We're going to start off by visiting our workspace settings, going down to destruction and deletion, and click on Q Destroy Plan. After we type in the name of our project and click on the button, this is going to run the Terraform Destroy on our workspace. Now, do not worry, Terraform will only manage what Terraform knows about. So if you have other AWS infrastructure managed by separate projects, they will not be affected by this destroy. We have the option of validating this all within the output of 211 resources being destroyed shown here. In our case, we're going to go ahead and add a comment when we confirm. We're going to say goodbye to our lab, and then we're going to click on the confirm, and this will initiate the destroy phase. And again, hitting that ludicrous speed. Here we can see all of the resources now being deleted by Terraform. If we return back to the EC2 dashboard now, and I can refresh, I can see all of my instances have now transformed into the terminated state. And by refreshing the dashboard, I can see that we are all back to zeros, again, outside of the instances which are pending termination at this moment. But that's it. That's how we destroy everything by using Terraform. And tick in the final section, ladies and gentlemen, we have done it. You have successfully deployed a reference architecture of Palo Alto Networks VM series inside of AWS with just a few clicks of the button and a little bit of elbow grease behind your configuration files. Now, before I let you go, I have a couple of additional considerations based on the content that we've covered today. The first is around if you find yourself in a position to where you need assistance, right? Like maybe there's a project with a really tight timeline, or perhaps your team just would like some assistance in building the Terraform project for your environment. Please reach out. We do have a SKU that's dedicated towards professional services coming in and building out all these configurations for your specific environment. So we do this time and time again. The same team that creates these Terraform modules that we're looking at and supports them is the same team that will come in and build the environment specific to your needs. So keep that in mind as an option. Again, if you're either tight on time or you just need some assistance getting off the ground and running. The second point is I want to reiterate that the modules here are built for customization. Yes, in our demonstration today, we took the example repository and kind of ran with it. But I want to stress you will need at some point to modify either the Terraform configuration files or how the actual modules work themselves. And that's really the beauty of open source automation. You have that kind of capability. So don't think that you're relegated to these specific designs and it's got to look like this and it's got to do that. No, that flexibility is upon your shoulders to be able to create. Oh yeah, and one last thing. The modules themselves, they can be used by reference instead of cloning the entire project like what we did in our example. So if you wanted to, all you would need to do within your Terraform configuration file is really just copy this line that you see right here based on the design, and the source will point it to this registry and download the modules and all their source code whenever you do your Terraform init command. That's absolutely an option if you do not feel like you're going to need any customization to the modules and you just want some really clean code to be able to deploy this. Hey, these can handle that for you. But you got to make sure that you pass in the required variables or else the modules will not work. Thank you so much for hanging out. I hope this has been beneficial. If it has, go ahead, give it that thumbs up. Share it with your grandmother. Let everybody know what we're doing around here. Thanks again. My name is Calvin, and we'll see you in the next video.